Signals and systems, problems on signal classification, second part, series on signals and systems, lecture number 1.15. In the present session, the focus is on problems set around different properties, different classifications of signals. A few problems are set around are based on power and energy of the signals. Remaining problems are mainly based on periodicity nature of the signals. Now let us move further to start the course session. Now we do some refresh on energy and power signals before going to the actual solution of the problems. Here is given important properties of energy signals and also power signals in a box side by side so that we can have their comparison to energy signals. Signals whose total normalized energy is finite and non-zero. These are called energy signals. Signals whose normalized average power is finite and non-zero. They are called power signals. Energy E of a signal by definition is limit t tends to infinity integral t mod x of t whole square dt. In case of non-periodic signals, it turns out to be equal to integral minus infinity to plus infinity mod x of t whole square dt. Normalized power of a signal by definition is equal to P. P is the symbol. It is equal to limit t tends to infinity 1 by t integral t mod x of t whole square dt. For periodic signals, it turns out to be equal to 1 over t integral t mod x of t whole square dt. One more important point is non-periodic signals are energy signals, whereas periodic signals are power signals. Energy signals are time limited. Power signals, they are eternal. They begin at minus infinity. They extend up to plus infinity in time. So eternal. Power of energy signal is 0. Energy of power signal is infinite. Example for energy signal is a single rectangular pulse. If you consider a pulse train, then that train becomes example for power signal. To begin with, we consider a problem. This problem is determine power of the signal. Given signal is x of t is equal to a cos omega naught t plus theta. Notice it is a periodic signal. For a periodic signal, the power P is given by this formula, standard formula. P equal to 1 by T naught. T naught is time period, fundamental time period. Integration over one time period mod x of t whole square dt. It is equal to a square by T naught integration over T naught cos square omega naught t plus theta dt. It results in an amount equal to a square by 2. So power of the given signal is a square by 2. Another problem, it is based on energy signal or energy of the signal. Determine energy of the signal x of t. X of t is given as 3 triangle t by 4. Triangle function. Triangle function is like this. It spreads from minus 4 to plus 4. Origin is in the middle. For this, energy is required. Solution. The given signal spreads from -4 to +4. It is energy signal, non-periodic signal. Its energy E is equal to integral -infinity to +infinity mod x of t whole square dt equal to 9 integral -4 to +4 triangle square t by 4 dt. Its integration and the substitution of the limits gives us E as 24. So we consider another problem. Determine the energy of a rectangular pulse of width tau and amplitude A. Solution. It is quite simple problem. Only thing is we need to have the definition, mathematical defining relation of energy in our minds. E equal to integral -infinity to +infinity mod x of t whole square dt. Now signal width is tau. Therefore integration is minus tau by 2 to tau by 2 a square dt. It becomes equal to a square tau. Here the pulse is assumed surrounding the origin. Another problem, determine the power of a rectangular pulse train, each of width tau and amplitude A, assuming a time period t more than tau. Solution. Again, here also we do this problem by considering the definition of normalized power. P equal to 1 by t naught integral t naught mod x of t whole square dt equal to 1 by t integral minus tau by 2 tau by 2 a square dt. It turns out to be a square tau by t. Another problem, determine the energy of a sinusoidal pulse of width pi radians and amplitude A. Solution. E is equal to integral -infinity to +infinity mod x of t whole square dt equal to 0 to pi a square sin square theta d theta equal to pi a square by 2. Another problem, determine the power of a sinusoidal pulse train, each of width pi radians and amplitude A, assuming a periodicity of pi radians. Solution. P equal to 1 by t integral t mod x of t whole square dt equal to 1 by pi integral 0 to pi a square sin square theta d theta equal to a square by 2. Another set of problems, determine the power of following signals. Two signals are given. First one is combination of two sinusoids or cosinusoids. C1 cos omega 1 t plus theta 1 plus C2 cos omega 2 t plus theta 2. Omega 1 not equal to omega 2. Now expression x of t using in the definition of P power, one can find it equal to C1 square by 2 plus C2 square by 2. Second signal is x of t equal to d e power j omega naught t. Substituting in the definition of power, P can be obtained as d square. Now we spend some time on recollecting important aspects of signals periodicity, its definition, its nature, its properties. A CT signal is said to be periodic with period t if there is a positive non-zero value for t for which x of t plus t equal to x of t for all t. Notice in this definition, two aspects are there to be understood. First aspect is periodic signal is an eternal one. It starts at t is minus infinity and it extends up to t is positive infinity. It is eternal, everlasting, continuous. This is one aspect. The second aspect is there is a repetition there is a recurrence. A part of the signal keep on repeating. These two aspects should be kept in mind. The fundamental period T naught of the signal x of t is the smallest positive value of t satisfying the relation x of t plus t is x of t. A dt signal is said to be periodic with period n if there is a positive integer n for which x of n plus n is x of n for all n. So actually this is a dt version of definition of a periodic signal. The smallest positive integer n satisfying the above relation is fundamental time period, usually indicated by n naught. Some more points also we consider here. A CT signal or a DT sequence, when not periodic, they are non-periodic or aperiodic. Sum of two periodic DT sequences is always periodic, but sum of two periodic CT signals need not be so. For the sum to be periodic, the ratio of time periods must be rational number, ratio of two integers. A sequence obtained by uniform sampling a periodic CT signal need not be periodic. A CT sinusoidal signal sin omega naught t is periodic for every omega naught, but dt sinusoidal need not be so. In fact, a dt sinusoidal sequence sin omega naught and t with a sampling period of t is periodic only when omega naught t is a rational number multiple of pi with period n equal to 2k pi by omega naught t. Now another problem. This problem consists of several parts, 6 parts. In all these parts, we are required to find whether the signal is periodic or not. If periodic, we have to determine fundamental time period. These are all CT signals. First one is x of t is equal to 3 plus t cube. Second one is x of t is equal to 10 cos 800 pi t plus theta. Third one is x of t is 7 tan 8t. Fourth one is x of t is equal to 5 cos 18 pi t minus 2 sin 12 pi t. Fifth one is x of t is equal to 5 cos 18t minus 2 sin 12 pi t. Sixth one is x of t is equal to 5 cos pi t sin 4 pi t. Now we do these problems one by one. First one, signal is x of t equal to 3 plus t cube. The given signal never satisfies the condition for periodicity. The condition is x of t plus t is equal to x of t for any non-zero value of t, and hence it is not at all. It can never be periodic. Another problem. Here the signal is x of t equal to 10 cos 800 pi t plus theta. We know cos, sine, these are all periodic. So it is periodic. Given signal is periodic. Solution is the cos function is periodic with the period 2 pi. It is from trigonometry. Hence, omega naught t is 2 pi f t is 800 pi t. This 800 pi t has come from the given expression. It gives a time period of 1 by 400. Notice omega naught is 2 pi f and the required quantity T naught is 1 by f. Another problem. Here the signal is x of t is equal to 7 tan 8 pi t. Tan is also a periodic function, but note its periodicity is pi. For cos and sine it is 2 pi, but for tan it is pi. Hence omega naught t is pi f t is 8 pi t. This is from this given expression. From this, T naught can be determined as T naught is 1 by f. It turns out to be 1 by 8. Another problem, determine the periodicity and time period of signal x of t is equal to 5 cos 18 pi t minus 2 sin 12 pi t. Here in the signal there are two components. One is 5 cos 18 pi t, another is 2 sin 12 pi t, and both are periodic. Let us see whether the combination signal is periodic or not. Both the component functions are periodic with the time periods 1 by 9 and 1 by 6 respectively. Their ratio is rational. It is 6 by 9 or 9 by 6. So it is rational. And hence the given signal is, its time period is LCM, least common multiple of two periods, which is 1 by 3. Here a term is used, rational. What is rational? Rational number is one which is ratio of two integers. Let us move further. Consider another signal x of t equal to 5 cos 18 t minus 2 sin 12 pi t. Notice two parts are there in the signal. Both parts are periodic. Cos and sine functions are always periodic. Let us see this combination is periodic or not. Both the component functions are periodic with time periods pi by 9 and 1 by 6 respectively. Their ratio is irrational. Ratio has pi in it. Pi is not rational. Therefore, ratio is not rational. It is irrational. Here one point requires to be mentioned. Pi cannot be expressed as a ratio of two integers, so it is irrational. We may be tempted to think that pi is equal to 22 by 7, but equality pi and 22 by 7, this equality is only an approximate equality. It is not a perfect equality, and hence pi is not exactly 22 by 7. Hence pi cannot be expressed as a ratio of two integers. So it is irrational. When we come to the present situation, the signal becomes non-periodic as the ratio of periods of the component functions are. Another problem, given signal is x of t is equal to 5 cos pi t sin 4 pi t. The product can be expressed as a sum and both the components can be found periodic with time periods 2 by 5, 5 and 2 by 3. Their ratio is rational and hence the given signal is periodic. Its time period is LCM of the periods equal to 2. Here product of two trigonometric functions, one cos, one sine is given. First we have to express this product into sum of two trigonometric functions, and it can be expressed using sine a plus b sine a minus b, that formula. Each one then is a periodic function. Their time periods can be calculated. It is found they are 2 by 5 and 2 by 3. Their ratio can be seen as rational, and hence it can be easily said that the given signal is periodic. Time period is LCM of the two periods, which is equal to 2 in the present case. These are some of the problems which I want to share with you along their solutions. We come to an end to this session. Before closing, let us recollect what we have done in the present session. To begin with, we considered two problems which are based on classification, power signals, and energy signals, and then we moved to solve a set of problems which are based on periodicity of combination signals. Hope this session is useful to you. We meet again in another session with a new topic soon.